I'm Sujani, faculty in physics at Institute of Aeronautical Engineering. Today we are going to discuss about the applications of laser. So this is the last topic in the module about lasers. We have discussed a few important things in laser, and today we'll be discussing about the applications of laser. In applications of laser, we will also try to understand the basic terms that are involved in laser, and then we'll be discussing the applications of laser in different fields. In each field, where scientific field, then industry, medicine, and also in laboratories, how we are going to use this laser, we are going to understand the applications. Now, first thing, when you are using a laser, you need to understand what a laser is. Laser stands as an acronym for light amplification by stimulated emission of radiation. L stands for light, A stands for amplification, S stands for stimulation, and E for emission, and R for radiation. So that is how we get the acronym laser. Now coming to the characteristics of laser, it is highly monochromatic. It has got high degree of coherence, high directionality, and very bright. Monochromaticity is always related to single wavelength. It is a light of single wavelength. Coherence here means they are in phase. They will be having the same phase. Directionality means its divergence is very less. Divergence is very less. And it is very bright because its intensity is high. It is a very intense beam. Now, first thing you need to understand is stimulated absorption. So, what is stimulated absorption? When you see, generally the atoms are present in the ground state. Here, this is the atom. This is the ground state, whose energy is represented by E1. And this red block denotes the excited state, whose energy is denoted by E2. This is E1 and this is E2. The atom which is present in the ground state cannot go to the excited state on its own. We need to supply energy at least equal to the difference in energy between the two levels, E2 and E1. Only then the atom can make a transition to the excited state. So what we do now is we supply energy with the help of a photon. E is equal to h nu, represents the energy of a photon. And the difference should be actually equal to the difference between the two levels 1 and 2. So we are supplying an energy which is equal to the difference between the two levels. So before absorption, the atom is in the ground state and we are stimulating it with the help of an external photon. And once this atom absorbs the energy, so what happens after absorption? The atom which is in the ground state will now make a transition to the excited state by absorbing the energy. So let us see the definition. If a photon of energy h nu 12 collides with an atom present in the ground state. So this photon is colliding with the atom which is present in the ground state. then the atom completely absorbs the incident photon. This atom will absorb this energy and makes transition to excited state. So what is transition? Transition is nothing but the movement of atoms from lower level to higher level or higher level to lower level. So here we are seeing the transition from lower to higher level. So we are calling it as stimulated absorption. Stimulated because without stimulation, the atom cannot go to the excited state. So we are stimulating it. So after stimulating, the atom is absorbing the energy and then making a transition to the excited state. So we are calling it as stimulated absorption. Now coming to spontaneous emission, the atom is now in the excited state. So E2 is the energy of the excited state. So this is the excited state and this is the ground state. The atom is now in the excited state. This atom cannot stay in the excited state for a longer time. It can stay there only for a limited time, which we call it as lifetime. The atom can stay in the excited state only for a lifetime, and after the lifetime is over, the atom will automatically or spontaneously come to the ground state. So the atom is now coming to the ground state. So when it makes a transition from the higher level to a lower level, the difference in energy is being emitted. So what is the energy that is emitted? H nu is equal to E2 minus E1. E2 is at a higher level, E1 is a lower level, and the difference in energy between E2 and E1 is being emitted in the form of a photon. And this process we are calling it as spontaneous emission. This process is called spontaneous emission. Now we'll see what is stimulated emission. This is the ground state. This is the excited state. After absorption, the atom is in the ground state. Still the lifetime is not over. So before the lifetime is over, if we can stimulate this atom with an external photon, so we are stimulating the atom which is in the excited state with the help of a photon H nu 12. We are stimulating. That is, before stimulation, the atom is in the excited state, and when it is still in the excited state before the lifetime is over, we are stimulating with the help of an external photon. Then what happens? The atom will make a transition to the ground state. So when it is coming to the ground state, what will happen in this case is we will have coherent beam that is produced, because EH2 nu 21 represents the emitted photon. The difference in energy that is being emitted, H nu 21, and there is an incident photon. A photon is incident, and because of that, the transition is taking place. And if these two are in phase with each other, we get a coherent beam. So a photon having energy H nu 12 impinges on an atom present in the excited state, and it will stimulate it to make a transition to the ground state. So it is not happening on its own. It is occurring due to the stimulation of the external photon. So what is happening here is it gives off a photon of energy H nu 21. And the emitted photon is in phase with the incident photon, and they are coherent. So we are calling it as stimulated emission. The entire process of emission of electron by stimulation, we are calling it as stimulated emission. And we have seen the definition for lifetime, the time for which the atoms can stay in an excited state, we are calling it as lifetime. And then metastable state. Metastable state is also an excited state where the atoms can stay for a relatively longer time. So if we are talking about a metastable state, we will have a minimum of 3 levels: E1, E2 and E3. 3 different energy levels. So this is the ground state where the atoms are there actually. When we stimulate, say the atoms are going to the excited state. In this excited state, the atoms cannot stay for a longer time. Once the lifetime is over, they make transition to the ground state or to the next lower level. So when there is a transition, what happens here is there may be atoms here. But in E2, the atoms can stay for a relatively longer time. So we call this E2 as metastable state. This E2 will be the metastable state. So E1 is the ground state, E2 is the metastable state, E3 is the excited state. The atoms will actually be in the ground state, and after absorbing energy, they go to the excited state. And from excited state, they come to the lower energy level, that is metastable state, where they can stay for a longer time. Now coming to population inversion. If N1 be the number of atoms present in the ground state, when we are talking about the ground state, energy E1 and the excited state E2, N1 is the number of atoms in the ground state and N2 is the number of atoms in the excited state. Now, if you see the condition here, N1 is greater than N2. Usually, the number of atoms present in the ground state is higher than that in the excited state, and we write the condition as N1 greater than N2. And by using some mechanism, some pumping mechanism, if we can excite these electrons to higher level, means these atoms have now come to the higher energy level. Now, if you see the condition in the second diagram, we see the number of atoms in the excited state, N2, more than N1. So, this condition we call it as population inversion. The process of making N2 greater than N1, we are calling it as population inversion. And population inversion can be achieved by different mechanisms: optical pumping, electrical discharge, then inelastic collision of atoms, thermal pumping. Thermal is always related to heat, then chemical reaction. And when we come to the types of lasers we are seeing, we have gas lasers, helium neon laser and CO2 laser. We have already discussed the helium neon laser in detail. And then we have solid state laser, that is ruby laser and glass laser. We have discussed the ruby laser. And in semiconductor lasers, we have homojunction and heterojunction laser. These are the different types of lasers we have. And the steps that are involved in lasing action. Whenever we need a laser, there are different steps that are involved in lasing action. 3 steps we are going to see: pumping, population inversion, and stimulated emission of radiation. So these are the 3 steps we follow for getting the lasing action. So in pumping, what we see here is the process of sending the atoms from lower energy level to higher energy level. And we use different pumping mechanisms. For ruby laser, we use optical pumping. For helium neon laser, we use electric discharge. And for semiconductor laser, we use direct conversion. And for CO2 laser, we use chemical reaction. Now, population inversion can be achieved with the presence of a metastable state. A metastable state where the atoms can stay for a relatively longer time. So when we have a metastable state, the condition of population inversion can be achieved very easily. Then once the condition of population inversion is achieved, we use stimulated emission. Means we will stimulate the atoms that are present in the excited state to make a transition to the ground state. And when the transition happens, the incident photon and the emitted photon are in phase and they produce coherent light. Now coming to the laser system, it will consist of three basic parts. So the first one is the active medium, the second one is the energy source, and the third is the optical cavity or resonator. So in the active medium, we will see different energy levels that are suitable which support the laser action. And in energy source, we use the source of pumping. The pumping mechanisms we use to pump the atoms to higher level. And the optical cavity where we take the active medium and keep the reflectors so that we achieve the optical feedback. And this is the block diagram for a laser system. This is the block diagram of a laser system. So the first part is the laser medium. Whatever we take here is the laser medium or the active medium is the first one. Second is the pumping system. Any type of pumping we may choose, the optical pumping or the chemical pumping or the electric discharge. That is the second one, optical pumping system. And the third one is the optical cavity, which will have two reflectors. One fully reflecting and one partially reflecting. I may call this as the cavity, in which we are taking the active medium and putting two reflectors. So these are the three very important parts in the laser system. Now we'll try to see the applications of laser. First, laser in communication. In communication, where we say it is, I can say telecommunication, it has got lot of applications. Laser are used in optical fiber communication. Optical fiber means communication where we are using optical fibers. And a light source to transmit audio and video signals and data to long distances without attenuation and distortion. This is very important. In previous days, we used to use cables, the metal wires to transmit information or to transmit communication. But nowadays, we use optical fiber. And in optical fiber also, where light is used as a carrier to transmit the signal. So this light source, if it is a laser, so it can easily transmit audio and video signals to very long distances without attenuation. Attenuation here means there is no loss of signal, and distortion means there is no change in shape of the signal. Means whatever the signal that has to be transmitted will be transmitted without any loss of signal very easily with the help of laser. Then laser beam can be used for communication between Earth and Moon. If you can imagine the distance between Earth and Moon, it is very large. Now when we are using laser beam, because laser beam, the divergence is very less, it can travel very straight. So when it has to travel long distances, when it goes straight, always the straight line distance is the shortest distance, and therefore we use laser beam for communication. So when we have satellites, you see in the figure, we are seeing lasers in satellite communication. So we have a station here on the Earth and we have a satellite. When we have to communicate from the Earth to a satellite, we are using the laser beam. The laser beam is sent and it gathers the information and the signal is coming back. This is the transmitter and this is the receiver. So we are using laser beam for communication between the Earth and satellite. Then laser beam can also be used for underwater communication, as the laser radiation is not absorbed by water. So if you see underwater communication means there may be submarines inside the water, or you may have to find out sometimes the depth of the oceans or any mining that has to be done or petroleum or any type of activities that we do underwater. We use laser beam for communication. So a laser radiation is not absorbed by water. Therefore, we are using laser beam for communication underwater. Then coming to laser in industry. Industrial purpose where we are using, they are used for welding. Dissimilar metals can be welded using laser. When you have to join two different metals, means when you make huge boilers, especially during the manufacturing processes in industries, they may have to do some joining of metals. So then they can be joined or welded with the help of laser. So always we hear about laser welding. So dissimilar metals can be welded using laser. And holes with controlled precision can be drilled in steel, ceramic, diamond and alloys using laser. When you have to drill holes, these holes have to be very precise, means you cannot make them big or you cannot make them small, depending upon the requirement. Here we are seeing a diagram here, drilling steel foil for high density filters. Even in manufacturing, especially in chemical industry, they use lot of filters. So when they use filters, the size of the holes, depending upon the usage, the size of the holes is decided. And the holes have to be very precise. It may be in steel, ceramic or diamond. If you see ceramic is very brittle, so you have to do it very carefully. And we have seen that laser is unidirectional. It is very sharp and focused. So we can make precise holes in materials like steel, ceramic and diamonds. Diamonds, when they are using it for jewelry, so they have to drill holes to make it fit into gold or something. So they will be using the laser to make holes in diamond. And then laser is widely used in electronic industry for trimming the components of ICs, integrated chips we see. So whenever they have to use these components, they have to be trimmed before they are inserted into the circuit. So laser is used in electronic industry in trimming the components. Then laser in medicine. We generally hear about laser surgeries. So lasers are used in eye surgery, especially they are used to attach or detach retina. Retina, you know, the screen that is behind our eye, which is responsible for the formation of the image. Whenever there is a defect in the retina or sometimes with age, also the retina may get damaged or it may get detached. So we use laser. Laser is mostly used in eye surgery for attaching the retina. Then laser is also used for treatments like plastic surgery, skin injuries, and also for removing moles, tattoos, tumors that are developed in the skin tissue. So why we are using laser again for plastic surgery is because it is very sharp and fine beam. So whenever they have to do surgeries, especially related to plastic surgery, they have to be very careful that the other skin is not affected or the other parts are not getting affected. So for skin surgeries or plastic surgeries, also for removing the moles or tattoos, they are using this, and also for removing the tumors which may be harmful. Now, when there are tumors inside the body, if it has to be removed, if you are using laser, the other cells will not get affected and only these dead cells or the tumor cells can be removed very easily without affecting the other cells surrounding it. Then laser is used in stomatology. Stomatology is nothing but the study of mouth and its disease. So whenever they have to use in a treatment of ulcers in the mouth or cancer in the mouth, No, they use laser. Again, the same reason, because of its characteristics. So here you can see the diagram for laser that is used in stomatology. That is the treatment in mouth and its disease. And here we are seeing the laser for tattoo removal. So the tattoos that are made, they say they are permanent, but they can be removed with the help of laser. Some more applications of laser in medicine. Laser radiation is sent through optical fiber to open the blocked artery region. No, especially when they are performing these heart related surgeries, especially people when they are suffering with heart attack, they are having blocked arteries. There may be some plague which will block their arteries, and because of the blocked arteries, the blood flow is not there, and because of the lack of blood flow, they may have a cardiac arrest. So before that, what they do is, if they are detecting a blocked artery, they can open them with the help of this laser radiation. The blockages in the arteries can be removed with the help of laser radiation. Then laser is also used to destroy kidney stones and gallstones. So some people have a tendency of the formation of stones inside the kidney. So when these stones are detected inside the kidney, they first, with the help of a sonography or something, they detect the size of the stones. And if the size of the stone is small, they use a laser to destroy the kidney stones. When they send these laser uh, light, what happens is these stones will just become powder and they can be removed very easily without any surgery. The same thing when there are stones in the gallbladder, which produces the bile juice. So even when there are stones, it becomes very difficult for the digestion of the food. So these gallstones also can be removed with the help of laser. Okay. Therefore, the surgeries can be avoided when we are using laser. So laser are also used in cancer diagnosis and therapy. So in detecting the cancer also, sometimes what they do is, when there is a tumor inside the body, the cancerous tumors, to detect the size of the tumor, they have to locate where it is and what is the size of the tumor in diagnosing that. And also in therapy, when they are sending the radiation to remove the tumor without getting the other cells affected, they use the laser, radiation therapy. Then lasers are also used in blood loss less surgery. So when we are using laser, there is minimum loss of blood. So we are calling it as blood loss less surgery. Then lasers are also used to control hemorrhage. So sometimes what happens is, there may be a damage in the brain hemorrhage, they say. So because of any accident or something. So this can be avoided with the help of using laser. And using CO2 laser, liver and lung treatment can be carried out. Liver and lung, which are very sensitive parts in the body. So they are using a CO2 laser, which is a high powered laser which can be used for treatment of liver and lung. Then lasers are used in endoscopes to detect hidden parts. So what is an endoscope? Generally we hear about endoscope whenever they have to do some diagnosis internally. So endoscope is a fiber. It consists of an optical fiber, we say. There will be a camera at the end. So they will send this endoscope inside the body with the camera, and the light is sent. So with the help of that, they can find out whatever the problem that is there in the hidden parts. They can detect the problems that are there using endoscope. Now coming to laser in military. Focusing of high energetic laser beam for few seconds destroys aircrafts, missiles, etc. They are called as death rays. So in military purposes, means wherever we have a country tries to protect against the enemies, whenever they find any uh, aircrafts or missiles coming from the other side, from the enemy side, if they have to eliminate them, what they do is they send high energetic laser beam. And this laser beam, even if it is incident on that missile, for a few seconds, it can completely destroy the missile. So we can stop it from reaching us, the aircrafts or the missiles. So they are calling these rays, these laser beam, high powered laser beam, which when subjected to few seconds also can destroy them. We are calling them as death rays. And also the vital part of the enemy's body can be evaporated by focusing a highly convergent laser beam from a laser gun. Maybe this is also when there is a fighting that is going on, then they may also use this laser beam to send it into the enemy's body. Suppose they are sending it, they are focusing it onto their eyes. Then what happens? By focusing this highly convergent beam with the help of a laser gun, then the body part will get evaporated. So the eye may get damaged. So they may not be able to see. So all these things are happening in military. Then coming to LIDAR, light detection and ranging. This is used to estimate the size and shape of distant objects or war weapons. So when there is a war going on and there are weapons that are sent from the enemy's side. So if they have to know where they are stationed, what type of weapons they are using, what is the size of the weapons, shape of the weapons, so that they can counter attack them. So they are using this LIDARs. LIDAR means light detection and ranging. They will be sending the light. You can see in the figure, laser beams of LIDAR. So when they send the light and they receive the light back, so with the help of this, they will be able to know the size and shape of the objects or the war weapons. And in the second diagram, we are able to see the laser gun, which is a very powerful beam. This beam, when it is incident on the body part of the enemy, it will evaporate those body parts. Then coming to laser in computers. By using laser, a large amount of information or data can be stored in CD-ROM, or their storage capacity can be increased. So with the help of laser, because it is very fine beam, so we are able to store more amount of data in a less space. So they are also used in computer printers. We are going to discuss in detail how it is used in computer printers. Then coming to laser in scientific research. Laser beam can initiate chemical reactions. They are used to study the nature of chemical bonds, and they can also break molecules. So whenever you have to study about a chemical reaction, how the reaction is happening, or if you have to initiate a reaction also, we can use the laser beam. And laser is also used to study or estimate the size and shape of biological cells, such as erythrocytes. When we are talking about these cells, biological cells means the cells that are present inside our body, to estimate the size and shape, they use laser. So sometimes when we see our medical reports, then they are writing there what type of laser beam is used to study the cell size or to make the report. So laser are used to find the size of the dust particles also. Sometimes when they have to predict, or they are talking about the environmental conditions or the pollution that is there in the air, so they have to talk about the size of the particles and also know where from this pollution is coming. So they use laser to find the size of the dust particles. And also laser is used in counting the atoms in isotope separation. So where in chemical industries, what they do is, if they have isotopes, and in isotopes, if they have to count the number of atoms, then they use laser, because atoms are generally you cannot see them, but with the help of a laser, they can be counted in isotope separation. Now the other applications of laser we see, they are used in holography for recording and reconstructing of a hologram. You see a hologram is a three-dimensional picture. So either if you have to record or reconstruct it also, we use laser. Then laser also used to measure constantly changing distance between the moon and earth by astronomers. So astronomers are those who study about these celestial objects. So whenever we see, because of the movement, we know that these planets are moving around the sun. When they are moving, the change of distance is happening continuously. So this laser can be used to find the changing distance between the moon and the earth. Then laser are also used in plastic industries to unite monomers to polymers. Polymers have got lot of applications. So when they have to unite or mix these monomers with polymers, they use laser. And then laser is also used to develop hidden fingerprints and to clean delicate pieces of art. So when this is used, when there is a crime that is happening, they take the fingerprints, and with the help of the fingerprints, they are able to detect the culprit. So laser is used to develop the hidden fingerprints, and also when they have to clean delicate pieces of art pieces will be there. There may be dust or something where it has to be cleaned. So even for that we are using laser. Now I have listed many important applications of laser in medicine. So we have discussed bloodless surgery, then destroying the kidney stones, then cancer diagnosis and therapy, then detecting or detaching where we have a retina that is detached, to attach it or to correct the curvature of the eyelids. Sometimes the curvature of the eyelids gets distorted. So to correct it also they use the eyelids. Then fiber optic endoscopy is used when it has to detect ulcers inside the intestines, especially they send this endoscope inside with a camera and they find it. Then liver and lung diseases can also be treated, we have seen. Then laser is used to study the internal structure of microorganisms and cells, biological cells that are present inside the body. If they have to study the structure, they use laser. Then they are used for chemical reactions. They are also used to create plasma, to remove tumors, and it is also used in dentistry to remove the caries or the decayed portion of the teeth. When they have to clean or remove the decayed part of the tooth, they use laser. And also for cosmetic treatments, that is for plastic surgery, for skin treatment, for acne treatment, or cellulite and hair removal also, they use laser. Then in communication, we have seen, especially in optical fiber communication, to send signals over large distances with less loss. There is no attenuation or minimum attenuation and distortion, we have seen. Then it is also used for underwater communication, we have seen. Space communication, that is between the satellites, radars and satellites. Then applications of laser in industries. In industries, we are using it to cut glass and quartz. Then in electronic industries, we are using it for trimming of components, that is resistors and also ICs. Then heat treatment in automobile industries. It is also used to collect information about the prefixed prices of various products in shops and business establishments for the barcode printed on the product. So whenever we go to a supermarket, so you buy a product, there is a barcode on it. So they use a laser beam to read the barcode. So that is nothing but the collection of information regarding the price or the quantity is done with the help of the laser light. Then ultraviolet lasers are used in semiconductor industries for photolithography. So photolithography is a method that is used for manufacturing PCBs. What are PCBs? They are printed circuit boards and microprocessors by using ultraviolet light. So ultraviolet lasers are used there in semiconductor industries. Then lasers are used to drill aerosol nozzles and control orifices. Orifices is nothing but small opening, a very small opening with a required precision. So when you have to make orifices with controlled precision, then also we use laser. And in science and technology, we are seeing it helps in Brownian motion of particles when we have to see about the movement of particles inside a structure. Then with the help of helium neon laser, it was proved that the velocity of light is same in all directions. They have used this to prove that the velocity of light. We all know that there's nothing more than the velocity of light, and it is the same in all directions. And with the help of laser, we can count the number of atoms. We have seen the example in case of an isotope. We are able to count the number of atoms. It is used in computers to retrieve the stored information from a compact disk. When you are storing the information in a disk, it can be retrieved with the help of this laser. So they are used to store information also. Store information or data within a minimum space, or you retrieve the stored information. Then they are used to measure the pollutant gases and contaminants in the atmosphere. To the extent of finding out the size of these pollutants also is possible using laser. And laser is helping us in determining the rate of rotation of the earth accurately. How is the earth rotating? That also can be predicted with the help of laser. And laser is used in computer printers. And it is also used for producing three-dimensional pictures. We have seen holograms. So all these are the uses in science and technology. So we have discussed many applications in various fields. For more applications, you can refer to books, or you can also Google search and find out and know about each application in detail. Thank you. See you again in the next lecture.
Like, share and subscribe. Hit the bell icon for more updates.